In this lecture, let us discuss about maximum entropy classifier, which is a probabilistic classifier. That means it predicts the probability of each possible output label, and it is widely used in various NLP tasks like parts of speech tagging, named entity recognition, text classification, etc. And this maximum entropy classifier is based on principle of maximum entropy, which prefers the most uniform distribution while still matching the constraints imposed by the training data. And coming to the working process, see here it will consider set of features as input, which is represented as fi of x comma y, where x is the input. That means here the input can be either a word or a sentence, whereas y is the label. So the kind of label which we are going to attach to that particular input. So here for word, we can give any POS tag, or else you can find out sentiment of one particular sentence based on the positive and negative words present in the sentence. And output will be a probability distribution over possible labels which are given or which are defined like this. So you can see P of y given x equal to, so this is the formula where fi of x comma y is a feature functions capturing characteristics of the input label pair, and this lambda I is a weights learned from training that indicate the importance of each feature, and this zx, it's a normalization term which is also called as partition function that ensures the probabilities across all possible labels y sum to 1. So we want to assign a POS tag like noun, verb, determiner to a particular word in a sentence with the help of this maximum entropy model, and a probabilistic classifier that uses feature-based modeling. So here you can see this process step by step. First step is problem definition, where a word in X in a given sentence, including its context words, that means surrounding words, and also set of possible tags y equal to y1, y2, and so on, yk, such as, so here you can take POS tags as noun, verb, adjective, etc. Whereas the sentiment classes can be positive, negative, and neutral. So this X represents a word, whereas this Y represents the respective tag we assign to that particular word. So this tag can be either a POS tag or it can be a sentiment class. And here we want to compute, or we want to find the best tag for the X. And for that, we are using this equation y hat equal to argmax P of y given X. And this will mainly evaluate the probability of each tag y given the word X. And it will choose the tag with the highest probability. So this is where the maximum entropy classifier works. Like it calculates these probabilities using the features extracted from X. So using the features extracted from words as well as the candidate tag Y. Step 2 is feature function design. So feature functions, they describe the specific condition or patterns between the input X as well as label Y. So they are actually the binary functions, and you can define them like this. So each feature fires 1 or doesn't fire, which is represented with 0 for a given input comma tag pair. So here we'll take multiple inputs. X represents input, Y represent tag. So if appropriate tag is assigned to that particular word, then in that case, this feature will fire. So the value will be 1. If the feature I is active for this pair X comma Y. Say if the appropriate tag is not assigned to that particular word, In that case, the value remains 0. So we'll consider that as fire and not fire cases. So these are, say, you can take some common examples for this. Say, for example, if the current word is flies and the tag assigned to that is VBZ. In that case, this f of xi, x comma y value will be 1. If this condition is true for a given word and tag 0 if this condition false. Say, see, if this tag VBZ is appropriate for this word flies, then value 1 will be assigned to that. Otherwise, value 0 will be assigned to that. At the same time, we'll consider one more feature like this. Words end in S. And say the tag assigned to that is NNS, plural noun. So this actually captures morphological patterns relevant to tagging. And also the previous word, say if it is time and the tag assigned to that is VBZ, then also we can assign or we can calculate this fi of x comma y. If that tag is suitable for that word time, then value will be 1, otherwise value will be 0. So this actually incorporates contextual information. So like that, we can take multiple features and each feature works in a special way. So each of these is a separate feature function, and also the maximum entropy model combines many such features in order to decide the best tag. So it won't just consider single feature and it will assign the particular tag to that. So it will consider multiple features like this, and then appropriate tag will be given to the word present in the sentence. Then step 3 is modal definition. It estimates the conditional probability of a label y given input x. So this one, probability of label y given input value x. And this is a notation where this fi of x comma y, it's a binary feature function which we take from step 2. And the value can be either 1 or 0. So we already saw that here. So this value, based on these features, this value can be either 0 or 1. And that value will be provided as input to this equation. And we have lambda I, which is the weight of a feature. And this value is learned from the training data. Then we'll calculate this summation, which computes a score for input comma. So this is input and this is tag. So this summation, it will compute the score for each input comma tag pair. So this is a pair. And the exponential function, this exponent here, it converts the score into a positive number. And z of x, it's a normalization factor that ensures all probabilities add up to 1. So you can see how the z of x is calculated again. So it is defined like this. So for every possible tag y dash, it will compute the exponentiated score. And the summation will be considered. So sum of all these scores will be done in order to get the z of x. So finally, that value will be substituted here. And this maximum entropy model gives a valid probability distribution over all possible tags. And step 4 is training the model. So we want to learn the best weights like lambda equal to lambda 1, lambda 2, and so on, lambda n for each feature function fi so that the model predicts the training data well. By maximizing the log likelihood of the training data, so this is the log likelihood of the training data, D. So you will be using this formula for calculating that. which means we are trying to make the model assign high probabilities to the correct outputs y for each input x. So based on the appropriate tag, so we are assigning high probability to the tag which is most suitable for that particular input, or the for every input value or input word. So for that we are using the optimization algorithm to find the best weights. And here we have gradient ascent, which is a step in the direction of gradient to increase log likelihood. Then LBFGS, an efficient quasi-Newton method often used for logistic regression. And improved iterative scaling, which is a classic method specific to maximum entropy models. Then gradient of the log likelihood will be considered. So which means how much to change. So here we need to change this lambda I. So how much change should be done to this in order to increase this log likelihood value. So here this E data of Fi, it is the expected value of feature under the training data, whereas this E model of Fi is the model's predicted expectation of that particular feature. And step 5 is making predictions. So here we are giving the new input X like word or context, and we are providing training weight lambda. Input word X and training weight lambda. We want to predict the most likely tag, which is represented with Y hat for that particular input. So based on this X and weights, we are trying to predict Y hat, that is the appropriate label for that input word X. So for this, first we need to compute the score. So this is the notation for that. For each possible tag Y, we need to compute a score using this. So this is just a weighted sum of feature values of X and Y. So we need to find out how well does this tag Y fit input X according to the model. How well this tag is suitable for this input word. So that's what we are trying to find. And after that, we need to turn these scores into probabilities. So we calculate probability for each tag with the help of this equation. Convert all the scores into probabilities with the help of softmax function, which makes sure that all probabilities are positive and the value will be, or the sum will be 1. After that, we need to pick the best tag. So you need to find out the steps here properly. First step is we are calculating the scores, then converting these scores into probabilities, and then we need to pick the best tag. So how we'll pick that? Based on the probability. The one or the tag which is having highest probability will be selected that for that particular word. So we need to choose the tag.